Today, we're going to be looking at factoring by grouping. This is the method by which we can factor virtually any polynomial we come across. We're going to start with the simplest form of the polynomial, x squared plus 5x plus 6. What I need to remember when I'm looking at these things is I'm looking for both a product and a sum. The product in this case is going to be the product of the outside terms. So 1 times 6. Remember, there's a 1 in front of the x squared term. So that product is very clearly 6. Then I'm going to be looking for a sum, which is the middle term. In that case, it is 5. So, looking for a product of 6 and a sum of 5, the two numbers that I've come up with are 2 and 3. They have a product of 6 and a sum of 5. I'll start by rewriting the polynomial with that middle term. X squared plus 2x plus 3x plus 6. Notice that the 2x plus 3x is the 5x that I was looking for. That is the sum. Now I can use my strategies for using GCF to factor the rest of this polynomial. Looking at my first two terms here, I see that they have a greatest common factor of x. This would be x times x plus 2. Looking at my next two terms, I see these have a common factor of 3. This is 3 times x plus 2. And this is the important part. I can see that this x plus 2 matches this x plus 2. So I can rewrite that entire part, x plus 2, and then from this first one, I'll get an x. From the second one, I'll get a 3. So I have factored this polynomial, x squared plus 5x plus 6, as x plus 2 times x plus 3. But now let's look at a little more complicated problem. I can see here that I have a lead coefficient of 3, 14x, and an 8. I need to find again the product and sum. So, I take my 3 times my 8, that's 24. I'm looking for a product of 24. And I can see from the middle here that I am still going to need a sum of 14. So two numbers that have a product of 24 and a sum of 14, well, that's 12 and 2. They have a product of 24 and a sum of 14. So with that in mind, I can now start to rewrite my polynomial. And I'll rewrite that as 3x squared, and I'll replace the middle term with those numbers that I found. 12x and 2x. Note 12x plus 2x is still 14x. I haven't changed the value, I've just changed how it looks. But now I can look at these first two terms. These have a greatest common factor of 3x. 3x times x is 3x squared. 3x times 4 is 12x. I can look at my next two. 2x plus 8. These have a greatest common factor of 2. That'll be 2 times x plus 4. And this is the important part. Since x plus 4 matches x plus 4, I can rewrite that. Then, from my first term, I will have 3x, and from this one, I'll have plus 2. And I have factored my polynomial as x plus 4 times 3x plus 2. Sometimes we try to get tricky with it. So I have here a polynomial that, again, I'm going to look for a product of 9 and a sum of 6. Two numbers that will multiply to 9 and add to 6. This gets confusing because a lot of times we try to think of two different numbers. But in this case, those two numbers are 3 and 3. 3 times 3 is 9. 3 plus 3 is 6. Having already established that then, we can rewrite our polynomial as x squared plus 3x plus 3x plus 9. That's a good place to start, so now I can use greatest common factor. The greatest common factor of x squared and 3x is x. This will be x times x plus 3. The greatest common factor of 3x plus 9 is 3. This will be 3 times x plus 3. Now, since x plus 3 matches x plus 3, I will write that as x plus 3. From the first side, I'll have x, and from the second one, I'll have plus 3. I ended up with x plus 3 times x plus 3, which could be written as x plus 3 squared. And then we have problems like this. This one looks like a binomial to me. In fact, this is a binomial called a difference of perfect squares. As I'm looking at this, though, I believe I can still use the strategy of factoring by grouping if I remember one very, very simple thing. I could rewrite this as x squared plus 0x minus 16. And now I can treat it like any other trinomial that I've seen in the past. I can see that it's going to need to have a product of negative 16. And I can see that it has to have a sum of 0. So, the two numbers that I can think of that would multiply to negative 16 but add to 0, well, it has to be one positive and one negative to add to 0, and they have to be the same number. So, for me, that is 4 and negative 4. I can now rewrite this polynomial with the sum 4x, negative 4x, minus 16. Again, I haven't changed the value of it, I've just changed how it looks. So now, I can look at these two and say they have a greatest common factor of x. This is x times x plus 4. I can look at the next two. And be careful, since they're both negative, I can say they have a greatest common factor of negative 4. And again, this is x plus 4. Now, just looking at these terms, I see they match. So I'll rewrite that as x plus 4. From the first one I get an x, from the last one I get x minus 4. X plus 4 times x minus 4 will produce a difference of perfect squares. To summarize, remember you're first going to look for a GCF for any trinomial. After you've taken care of the GCF, we can factor it by grouping. When factoring by grouping, we're going to look for the product of the outside terms, that's A and C. The two numbers we're looking for will have that product. The sum we're looking for will be the middle term, or B. We rewrite our polynomial, replacing the middle term with the numbers we discover, and we end the entire thing by simply factoring by grouping. We can use this technique to factor virtually any trinomial that can be factored using traditional means. Watch this as many times as you need to be successful with the work you have to do tonight.